This is intro to section 10.6. This is part 2 video. And in part 2 we're going to be talking about circumference, and we're also going to be talking about arc length. Now, the circumference of a circle is the distance around the circle. Now, the number pi is this symbol right here, is the ratio of the circumference of its circle to its diameter. Okay, so again, the circumference is really the distance around the outside. Circumference is very similar to finding the perimeter of any other shape. Okay, except for the only difference is a circle doesn't have sides. So when we find the circumference, we've got two formulas depending on what you have in the information. If you have the diameter, we say the circumference is pi times the diameter. Or if you have the radius, the circumference is 2 times pi times the radius. Now, they're going to ask you to leave your answer in a couple of different ways. Okay, it says here the number pi is irrational, so you cannot write it as a terminating or repeating decimal. To approximate pi, we use 3.14, 22/7, and we use the pi key on our calculator. Now, sometimes they're going to ask you to leave your answer in terms of pi. If they ask that, that means you leave pi in your answer. You don't calculate a decimal. Sometimes they'll ask you to use pi, and then you can either use the pi button on your calculator or you can use 3.14. Okay, so first example here says a car has a circular turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. How much further does the tire on the outside of the turn travel than a tire on the inside of the turn? Okay, so I need to figure out the circumference or the distance around of two shapes and find out which one is going around more. So I need to find the circumference of the outside circle and the circumference of the inside circle. Now, you'll notice on the outside circle, if we use, in this case we have the radius, so we would use 2 times pi times r. The radius of the outside circle is that distance right there. Again, the radius is from the center to the outside of the circle. So then it becomes 2 times pi times 16.1. Okay. Now, when I go through and I calculate this, I'm going to use the number 3.14 as pi. So this is really 2 times 3.14 times 16.1. So if you use a calculator on this and you use the pi symbol, your number might be just a little bit off. When I multiply those, the circumference of the outside tire, or the distance around the outside tire, is approximately 101.1 feet. Okay? So the distance around the outside of the circle, which in this case you'll notice here, I'm tracing it around the outside of the circle, is 101.1 feet. Now, what I need to figure out is the distance around the inside of the circle. Well, I need to figure out the radius. The radius of the inside of the circle, the inside circle, is not the same as the outside circle. So I got to find the difference between 16.1 and 4.7. That's going to give me the radius of the inside circle, which is 11.4. So the radius of the inside circle, which is here, is 11.4. So 2 times pi times r, 2 times pi times 11.4. Again, I'm using 3.14 as my pi, and I would get this to be 71.6 feet. Okay, now, as I'm looking at this and I'm calculating this, I need to know the difference between the two. I want to know which one traveled further and how much. So in this case, to find my final answer, I take 101.1 minus 71.6, and that's going to give me a total of 29.5 feet. So the outside traveled 29.5 feet more than the inside did. Okay, coplanar circles have, in this case, coplanar means they're in the same plane. have the same center. These are concentric circles, one circle inside of the other, and you'll notice here we use concentric circles on our last example. Okay, now as we talk about the arc length here, the measure of an arc is in degrees, while the arc length is a fraction of a circle's circumference. So when we talk about arc length and difference between measure of an arc and the arc length, the measure of an arc is always in degrees. The arc length is how long that distance is from one point to the next, and there's a huge difference. So an arc of 60 degrees represents 60 out of the 360 possible, or 1/6 of the circle. Its arc length is 1/6 the circumference of the circle. So this observation suggests this theorem, and this is where you're using this here. The length of an arc, this is the formula you're going to use here, and this is on your formula sheet as well. To find the length of arc AB, we're going to take the measure of arc AB in degrees, divide it by 360, take it times the circumference, and they do this with both the diameter and an example with the radius. Okay. Okay, so congruent arcs are arcs that have the same measure and are in the same circle or in congruent circles. So in this case, XY, arc XY, circle O, first of all, is congruent to circle P, which means that if you have an arc XY is the same as arc RS, then they're going to be the same to each other. Okay, let's find out some arc lengths here. So it says, what is the length of each arc shown in red? In this case, we want the length of arc XY. Well, what we need to figure out here is the measure of arc XY. And we're going to take that measure, divide that by 360, and we're going to take that times pi times the diameter, since in this case we have the diameter. Okay, so as I look here, the measure of arc RXY, you'll notice that this right here, this angle is 90 degrees. Well, remember, it's a central angle. The central angle is equal to the measure of the arc. So in this case, I know the measure of arc XY is 90 degrees divided by 360 times pi, and the diameter is 16. So 90 divided by 360, if I simplify this, you would get 0.25 or 1/4 times pi and times 16. And 16 divided times 1/4, or 16 divided by 4, is 4 pi. And we're going to leave this in inches. Now, you'll notice the directions say, leave your answers in terms of pi. That means pi is going to be in your answer. You're not going to calculate a decimal here. Okay? All right, let's take a look at the second example now. In the second example, we still want to mark, in this case, we want to find the arc length of arc XPY. Again, it's the red one. Well, we know that that is the measure of arc XPY divided by 360 times pi, and in this case, and times 2 times the radius, because we have a radius here, we don't have a diameter. Now, obviously, you could use the diameter if you wanted to. Okay, so how much is arc XPY? Well, here's XPY from X to P to Y. And it says here that it is 240 degrees. So I'm going to substitute that in. 240 divided by 360 times 2 times pi times the radius of 15. Well, when I divide 240 divided by 360, I do end up with 2/3. If you leave that as 0.67, that will be okay. You may have a slightly different number than what I have. And we're going to take that, 15 times 2 is 30 pi. Okay, which this ends up being 60 divided by 3, because 30 times 2, pi, which 60 divided by 3 is 20 pi, and our units are centimeters. Okay, so You can find the length of any arc. Remember, the length of the arc is different than the measure of the arc. Using the formula, the measure of the arc divided by 360 times 2 pi r, or times pi times the diameter. This concludes section 10.6 part 2. Don't forget to complete your 1 WSQ for both parts.